When factoring, we must look for the common factors in each of the terms and divide each term by the common factor. And usually we want to use the greatest common factor so that we factor completely. Now, if the greatest common factor is not evident, then it's helpful to use a prime factorization of each of the terms and then look for whatever is common to the greatest degree. So I mentioned prime factor. What is a prime factor? First of all, a prime number. A number that is divisible only by itself and 1. So that is divisible by itself and 1. So think about that. If we look at 1 is divisible by itself, 1. 2 is divisible by 2 because 2 divided by 2 is 1, and it's divisible by 1. 3 is divisible by itself. 3 is divisible by 3, and 1, and nothing else. When we get to 4, 4 is actually divisible by 4, but it's also divisible because it's 2 times 2. So 4 is not prime because it's divisible by more than just itself and 1. So I should say up here, only divisible by itself and 1. Okay, so let's take a look at the prime factorization of my example here, 15x plus 5y. So looking just at the first term, 15x, is made up of 15 and x. And 15 itself is made up of, well, it's equal to 3 times 5. Now, can I break either of those factors down into prime factors, or are they already prime? Is 3 divisible by anything else besides itself? No. Is 5 divisible by anything else besides itself and 1? No. So this is the prime factorization of 15. Okay? And so therefore, if we take a look at this right up here, 15x can be rewritten as 3 times 5 times x. Plus, now 5, if I do a prime factorization of 5, it's just 5, right? So this is 5 times y. Now, in order to find the greatest common factor, I want to look at each of my prime factorizations and find the highest power of each of the prime factors that are in common. So 3 is only in this first term. It is not over here. So 3 is not a common factor. However, 5 is a common factor. X is not a common factor, and y is not a common factor. So 5 to the power of 1, which we don't see it when it's not written, is the greatest common factor. So in this case, it's equal to 5. So I will factor out of 5. That will become my coefficient. Now, each term I must divide by the greatest common factor. So the first term is 15x. Sorry, not like that. The first term is 15x. Divide by 5, we get 3x. So the first term inside the bracket is 3x. And notice, it's the rest of the prime factorization. Plus the next term, 5y. Divide by 5 is just y. And notice, it's the rest of the prime factorization. So since we cannot factor these out anymore to get a common factor, we have factored with the greatest common factor and gone as far as we can go. In the next one, I encourage you to take a look at it, and if you want, pause the video and go ahead, see if you can do it by yourself. Otherwise, I'm going to start it. Okay, so we use a prime factorization of each of the terms. Looking at just the first term there, 4ax squared is made up of, well, I can factor 4 into 2 times a times x squared is x times x. That's a prime factorization of 4ax squared. Plus 2 does not factor any further, times a times x. Now, let's look at the greatest power of 2 that are common. Well, this one has 2 squared, this one has only 2 to the 1, so 2 to the 1 will be part of the greatest common factor. So we will start with 2. And the greatest power of a that is common, each of them are to the power of 1. So a to the 1 will be part of the greatest common factor. And x, this one has x squared, this one has only x to the 1, so we will have to leave it as x to the 1. That's our greatest common factor. Now, taking a look at what is left, we can do that in a couple of different ways. Like I did before, I can take my 4ax squared and divide it by the greatest common factor, 2ax, and we are left with 2x. We can also see that if we cancel out a 2, an a, and an x, we're left with 2x, right? So 2x and 2ax. Okay, well, this is very much like 2ax divided by 2ax. What's that? That's equal to 1. Remember that it's not a 0, it's a 1. If you ever wonder, just multiply back and make sure that you get the same terms as you have in your original. Okay, so we have one more example, and like I said, prime factorization is useful when the greatest common factor is not evident or not obvious to you. It's a useful way to find the greatest common factor. If you don't need to use it, then you don't have to, but it's just a way to do it if you cannot find the greatest common factors. So I'm going to show one more example of a prime factorization with this one. Now, we are going to factor each term individually, okay? And so maybe what we'll do is each one in its own color. So we'll do the first one in blue. The common factor, so the factors of 6 are 2 times 3. I could do a to the 5 and write out all the a's, but I think I'll just write it as this instead of 5 a's together, and x squared, okay? And then, so that's the first one. Let's do the next one in red, which is, let's see, we can call it, even though it's a subtract, we can call it a plus and just make one of the factors -3 times 3, right? Because that will make a -9. That's one way to write it. We'll do a cubed, and we'll do x squared. Cubed. The last one we will do in green, plus 3. I can't factor 3 out anymore, so that's just 3, a cubed, x squared. All right, looking at the numerical coefficients, the greatest power of each common factor. Is 2 common in all of them? No, so 2's out. is 3 common in all of them? And yes, we have a 3 here, we have a 3 here, we have a 3 here. And even if it was only the -3, we could have written this as -1 and +3, so it doesn't really, that would not affect it. So 3 is going to be part of the greatest common factor. Now a to the 5, a cubed, and a cubed. Okay, the greatest power that is common is a cubed. And then x squared, x cubed, and x squared, the greatest common is x squared. Leaving us with, all right, so I used the 3. I used up 2 of these. Actually, I used up 3 of them. And x squared, I used up all of those. So we're left with 2a squared. And the second one, we're left with -3. A cubed, we use them all up. X squared, that is 2 plus 1. We used up 2 of them, so x. And the last one, 3ax squared, we've used them all up, right? 3a cubed x squared. So this will be a +1. So to write that a little more neatly, 3a cubed, fix that, 3a cubed x squared multiplied by 2a squared minus 3x plus 1. Again, you can always check by multiplying back to see that you get the original expression. Okay? Thanks for watching. Bye.